Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Marty.
And I'm Chuck. Our phone tutors are waiting for your calls if you have math questions. Here in Bakersfield, it's 636-4357. San Luis Obispo and the outlying areas, you can call toll-free at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show online at dothemathonline.net. And look for us on social media. We have Facebook, Instagram, Twitter, YouTube, and
Skype.
Skype is coming
As
in.
of yesterday,
All right.
we had our first Skype calls yesterday on the program. And as a matter of fact, speaking of things new, we have new tutor today working in the tutor studio. So you'll want to make sure that you get that guy working a little bit and putting him through his training right now. We do have phone tutors available until 5:30. We have a very special guest coming on in just a few moments. But first, let's take a look at today's Math in the News. Well, we kind of started off Math in the News yesterday with Mary Lou and her Tinkerbell outfit getting us all ready for Halloween. And you were just saying that your daughter getting all ready for the holiday coming up and is going to...
Yeah, she's 6 years old. She informed us that she wanted to go as Darth Vader.
And what brought that on? Do you know? I mean, what...
I do. My brother took her shopping for her birthday, which is in October, and they saw this really authentic looking Darth Vader helmet at Target, and
you put it on her, and
and like, we got to buy this. And then she came home and just was like, I'm gonna be Darth Vader. Like, okay, that's awesome.
There you go. Well, you know what? This was an entire page out of the newspaper. I believe it was on Sunday, this past Sunday, and on here they've got some of the popular costumes from the years, starting back in 1983 all the way through today. Darth Vader, 2005. I mean, that was the hot one for the year right there. And Star Wars, once again this year.
And the original,
with the re-release in 1983, Princess Leia. But we're just going to take a look at some of the numbers here. 157 million Americans plan on celebrating the holiday.
Wow.
$6.9 billion. Okay. Just think about that. It's basically $7 billion spent on Halloween. Over $1 billion in adult costumes, and just about $1 billion in kids' costumes. The average person spends $74 on Halloween.
Oh, wow.
And I can tell you, I am under that amount right there.
Good for you.
One time I'm under the average, right, with the Halloween. Some of the favorite Halloween candy. Do you guys have a favorite Halloween candy? When you used to go out when you were younger, possibly, you were like, oh, I hope I get some of these.
Absolutely. Butterfinger.
Butterfinger?
Yes. It's good stuff.
Reese's.
Reese's?
Peanut butter cups or Reese's Pieces.
Not candy apples or caramel corn or anything like that?
You can't get those anymore.
No.
Yeah, they're difficult to get. I mean, most people are not going to give those out anymore.
Right.
Anyway, the favorite Halloween candy in a 50-state survey, Reese's, Kit Kat, and Butterfinger. So you guys are both right on there with both of those. How do you celebrate Halloween? 68% say they will hand out candy, because not everybody does it.
Right.
And for a variety of reasons, but you can't expect there's going to be 100% of people participating in this.
Right.
Decorate the home or the yard, 45%. Dress up, about 45%. Carve a pumpkin, about 40%. Do either of you have a pet?
Yes.
No.
Okay.
No.
So you know where I was going
Yes
with this.
and no. Sadly, I really want to.
13% dress the pets in costume.
Yeah, no.
I have never done that myself and don't see anytime soon that Babe will be getting dressed up for Halloween.
I did actually dress my cat up as a unicorn one time, but the little horn didn't stay on very long. It's a cat, right? So.
Yeah, how long is that
Yeah.
gonna last? Now it's a toy.
A unicat?
A unicat, yes, unikitty. Yeah.
All right, so I figured, you know what, there's a lot of numbers that we can look at right here, but there's one that I wanted to address, and it's in the smallest print on here. We'll go ahead and move this over a little bit, and we'll zoom in on that. Survey of 6,754 adults conducted September 1 through 8. The margin of error was plus or minus 1.2 percentage points. All right,
Yeah.
so I figured let's take a little look at that right there, because a lot of people will go, all right, I get that, I kind of understand it a little bit, but I'm not really sure how they come about this thing. And this could take a long time.
Yes.
All right, it could take a very long time to get into exactly how those are derived.
Right.
So we're just going to layman's kind of bring it down real quick. All right, so we're not going to go into the whole thing with all the stats and the formula and everything like that.
This could be
We could do the entire program.
we could do an AP stats class.
Right, just on how they come up with that number. But I figure let's go ahead and take a look at this. So when you want a percentage confidence, so you're like, all right, we want a 95% confidence level that we're going to be within this area, what we're looking for. All right, so you can see this Z value, all right, and how this all comes about is what I'm saying is it could take a very long time. So we're just going to bunch it all up and just show this. So if you have, you want 80%, you're at 1.28 for the Z value, 99 goes up. So anyway, let's take a look at how this is applied, all right? So what is the margin of error for random sample? You have 900 people, and you want a 95% level of confidence. So simply what we can do is we can say that by use of the table, the critical value of 1.96. So once again, we'll remember it's 95% level of confidence. The value is 1.96. So we go back and we look, 95% confidence level. The value is 1.96. So those are where we're getting the numbers from, that table. So we put the 1.96, divide that by 2 times the square root of 900. All right? The sample size of 900. So we put all that in and we come out with this decimal, so we know it's about 3.3%. Okay? If we have that same confidence level of 95%, but we up the number of people, so we're almost doubling the number of people. So the sample, is going to be different, obviously. So it goes from 3.3 to 2.5. So you're closer because you now have a larger sample that you're deriving the results from.
Right.
So the margin
theirs
of
was
error is smaller because you have more people.
And they had
Right.
what, 6,000?
Right, and their margin of
size?
error was plus or minus 1.2%. So they had close to 7,000 people that they did this with.
Okay.
But anyway, I figured that's just a little something that we can do, and since we're doing the math, we might as well take a look at something like
And
that.
we're hearing a lot about this now because of the polls for the election.
Right, exactly, because
who's
that's
in
what we
first
did
place,
in
who's
class
second,
today.
And there's always a margin of error, and they said even though one's higher than the other, they're within the margin of error because
So that's what they're talking about, that
So-
margin of error.
Exactly.
Which is exactly why I think it's important for students to see this a little bit. Not that we're going to do a stats class or an AP thing with them right now, but kind of how this all works.
Right.
All right, and that is today's Math in the News. Didn't ever think we'd go that far as
Yeah.
Halloween's
Z-score.
coming up. 636-4357 is the phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays. Right now, we'll go to the phones. A student from Stone Creek, Vincent. How are you today? Hello, Vincent. Is Vincent there? Hello, Vincent. Vincent is all right, Vincent's a 7th grade student from Stone Creek. I spoke with him in the tutor room a little while ago. He's working on adding mixed numbers. And I'm not sure if maybe they can run out the call right here really quick and we can take a look at, and I think they're getting the call back, getting Vincent back on the phone right now. So we'll find out which one happens quicker. We're going to get
If we can
Vincent
get-
back on the air
or we
real
can get his
quick, or
problem.
we're going to
Or we
get
get
problem
problem.
out here first. All right, I think we have Vincent back on air. Vincent, how are you?
Good.
Good.
All right.
And you are in 7th grade, correct?
Yes.
All right. Why don't you go ahead and read the math problem that you're working on?
2 over 2/5 times 3 and 8 over 9.
So it's 2 and 2/5.
Oh, 2 and 2/5, right? 2 and 2, is that what you said?
Yes,
Right.
but I have one question. How do I watch online, live?
Right, so I think he was having difficulty getting online, so it's dothemathonline.net.
Okay.
All right, so read the second number so that we can write that down and we'll go ahead and start working on it for you. So it was 2 and 2/5 times what?
3 and 8/9.
All right, so we may need to keep in mind, Chuck, as we go through this, that he
Sure.
may not be able to see it all
Okay.
right now or maybe trying to get to it. So this is going to be important for you, Vincent, to
Okay.
listen closely and write down things.
All right, so we're multiplying, and I just want to make sure I had it. 2 and 2/5 times 3 and 8/9. So you're multiplying these mixed numbers.
Yes.
And the important thing to remember is when you're multiplying these two numbers, we need to multiply a fraction times a fraction. What some people want to do is they want to multiply the 2 times the 3 and get a whole number, and the fraction times a fraction and get a fraction. And we can't do that. We have to incorporate the entire mixed number in the multiplication all at once, okay?
Okay.
So what we have to do is we have to change that mixed number, 2 and 2/5, into a single fraction.
Okay, so I changed them both into improper, and I got
Yes.
a really big number, and I'm not sure how to
Okay.
change it back.
So let's go to, so you said it exactly right. We're going to change each one of those into an improper fraction. So what's 2 and 2/5 as an improper fraction?
12 over 5.
And how'd you get that?
I used 2 to multiply 5, and then I added the 2, and the 5 I got denominator is 5 on the one.
The denominator stays the same, right?
Mhm.
And you went 5 times 2 and then added the 2 that was on top, right?
Mhm, which is 12.
And there's your 12/5, right?
Mhm.
Real easy to do. And we could go through everything, why that works, but that's a nice routine to get into. Multiply 5 times 2, that's 10/5, plus 2 more is 12/5. So we do the same thing with the 3 and 8/9, right?
Mhm.
So we're going to go 9 times 3. What'd you get?
Which one?
The 3 and 8/9.
Oh, I got
9 times 3,
27,
27, plus the 8,
which is 47.
27 plus 8, though.
27 plus.
What do you get?
I got 47.
Okay, except that would be 27 plus 10, right?
Mhm.
So 27 plus 8 was 27 plus 8, right?
Okay.
So instead of getting 37, we're going to get 15 in Caribbean one, aren't we?
35.
So that's going to be 35 over 9, right?
Yeah, 35.
35, right?
Mhm.
So let's see what we get here. Now, you said you get big numbers. Now, here's the question. What do you want to do? Do you want to multiply and reduce, or do you, in your class, do you reduce first?
I simplify the number.
So you're going to simplify the number by reducing these fractions first, right?
Mhm.
Now, we can't reduce 12/5 and we can't reduce 35/9, but we can reduce across, can't we?
Mhm.
We know that any factor on top, these are being multiplied, will reduce with any factor on the bottom because they're being multiplied. So we don't have to just reduce the 12 and the 5. How about the 12 and the 9, right?
Yep.
So what's the 12 and the 9 reduced by? What can you divide by?
12 and you can make the 12 fifths 12 over 1 and 35 over 9, 7 over 9.
Oh, okay. So you reduced the 5 and the 35. So the first thing you saw was, let's try this again. The first thing you saw was the 35 and the 5, didn't you?
Mhm.
And you said 5 goes into 5 how many times?
5 goes 5 times.
5 goes into 5 one time, right? You said that was going to be a 1, 12 over 1. And 5 goes into 35 how many times?
7.
7, and there's your 7, right?
Mhm.
I heard you say 12 over 1 and 7 over 9, okay? So you reduced the 35 and the 5. How about the 12 and the 9?
There's none for them.
There's no number, right?
Nope.
Well, 9 doesn't go into 12, right? But is there a number that goes into 9 that also goes into 12?
3?
3. We can divide them by 3. That's our greatest common factor, isn't it? So in this case, instead of dividing by 9, I'm going to go 3 goes into 9 3 times, doesn't it? And 3 goes into 12?
4 times.
4 times. So let's see what we get when we do the multiplication now. So instead of 12 times 35, which is some really big number, right? We're going to get 4 times 7. What's that?
4 times 7?
Yeah,
4 times 7 is 28.
28. And on the bottom, instead of 5 times 9, we're going to get 1 times 3. I can do that. That's easy. That's 3, isn't it?
Yep.
So instead of working with, and again, whatever 12 times 35 is, right, we're going to get a much smaller number, 28. All right? Now, can we reduce 28 over 3? Did we do all of the reducing over here that we could?
Yes.
We did, didn't we? There is no common factor of 28 and 3 except for 1, and that doesn't change anything, does it? So now we've got our answer, 28 thirds. Can we leave it that way? Can you
No,
leave your
we
answers?
cannot leave it that way.
Yeah, can't leave it as an improper fraction, so we have to change it back to what the original problem looked like, don't we? Let's change it back into a mixed number. How do you change 28 thirds into a
Just
mixed
to
number?
divide, see how many times 3 can go into 28.
How many times does 3 go into 28? How many times?
I'm doing it in 9 times.
9 times, because we know from over here that 9 times 3 is 27, right? And you got a remainder of
1.
1. So now what do we do with those numbers?
The
What's our-
remainder goes on top of the 3, so the answer is 9 and 1/3.
So the 3 stays on the bottom, right? It was on the bottom, it stays on the bottom. So that's part of our fraction. And the remainder, right, goes on top of that, which means the 9, that quotient, is our whole number, right? We have 9 groups of 3, right? That's the whole number. And so it looks like our answer to this problem is going to be 9 and 1/3. Okay?
Okay.
Great. Thanks for the call.
Nicely done, Vincent, right there. Do remember, if you have some more problems like that, we do have phone tutors available until 5:30. Vincent has just got himself entered into a drawing, and that drawing every single day is for a family 4-pack to go see the Bakersfield Condors. In studio with us right now, our newest ambassador. Did you know that was the title bestowed upon you now?
No.
You now are our newest ambassador because you now need to tell everybody you can about Do the Math. Can you do that?
Yes.
All right, nicely done. You're Coral, and why don't you let everybody know where you go to school and what grade you're in?
I go to school at Old River Elementary, and I'm in 6th grade.
Old River, a Wrangler, huh?
Yes.
Have you been there for a long time?
Yes.
Since when?
Kindergarten.
Oh, wow, so you've been there a real long time.
Yeah.
So you're going to be kind of happy to move on next year because you're going on to junior high.
Yeah.
But you've been at that school for 7 years.
Yeah.
How's 6th grade going?
Good.
Anything hard?
Gate.
Gate? Well, that's good. Like, it's supposed to be hard, isn't it? Okay. Well, you know what? We're going to take a look at one of your gate problems in just a moment, all right? But I think what we're going to do is we're getting ready to take a Skype call right now. All right, and I do believe we are ready. Is this Scott that we have on?
CJ.
Oh, all right. How are you today?
Good.
All right. As soon as you're ready, let's hear the math problem that you're working on.
I'm supposed to be writing each fraction or mixed number as a decimal, and I have 13 over 5 and 4.
So 13 over 5 is the first one?
Yeah, yeah. 4 13 over 25.
And 4/13ths?
Yeah.
Is that what I heard in the background?
And 4/13?
No, it's 4 is the whole number, and then 13 over 25 is the fraction.
Oh,
Oh, all right.
Mixed number.
So
Mixed
4 and 13/25ths.
4. Okay, let's try this again. Okay. So 4 and 13 over 25. Is that right?
Yes.
Yeah.
Awesome. Okay, and you're supposed to turn it into a decimal. Is that correct?
Yeah.
Okay, so if we remember our decimals and our decimal places, right? So our whole numbers would go on the left side of the decimal, right? Like these are the ones places, right? And then the tenths and the hundredths and the thousandths, correct?
Mm-hmm.
Okay, so there's a few ways that we could do this. We could, the nice thing is the 4 is already a whole number, correct? So I know that the 4, I know exactly where the 4 goes. The 4 is my whole number, so he's going to go on the left of my decimal place, correct?
Yes.
But the problem is, though, what do I do with the 13 over 25? So what you could do is you could do just long division on the 13 and the 25, because the fraction bar just really means divide, right?
Yeah.
Or we could try to get the denominator to be one of the place values, right? Because this one right here is tenths, which I don't think I can turn 25 into 10, because that would make it smaller. Or this one is the next one. Do you remember what the next one is after tenths?
Hundredths.
It's the, hundredths, right?
Mm-hmm.
So what you could do is you could turn the 25 into 100, because 25 does go into 100, doesn't it?
Yes.
Okay, so you could actually turn 25 into the 100, and that would be what would go here for your hundredths. So like, let's say you had, I don't know, like 62 over 100. That answer as a decimal is literally just 0.62 because it lands in the hundredths place, right? So we could turn 25 into 100. Does 25 go into 100
Well,
then? Oh, did we lose it?
It does.
Oh, okay. Or
So
we-
I lost track for a second. Where did
Oh.
62 come from?
Oh, I was just
Example.
making up an
Oh,
example.
okay. Because you were very close to what the answer was. I was going to just
Oh,
say,
really?
oh, all right,
Oh,
let's.
that was just a random guess. All right.
Okay.
Okay, my guess was
Good
pretty
guesser.
good. Thank you. Okay, so what you could do is you could go 13 over 25, right? And the goal is to turn the denominator into 100. So what do we have to do to 25 to turn it into 100? How many times does 25 go into 100?
So just think about quarters and a dollar.
Yeah, quarters and a dollar. So how many quarters are in a dollar?
4.
4. So I could actually multiply this by 4, and that would get me 100, correct? But if
Yes.
it's a fraction, right, we got to also change the numerator, the top number. So if I'm multiplying the bottom number by 4, I also need to multiply the top number by 4. So then we would just have to figure out how to multiply 13 times 4. And I'm going to go over here and actually multiply 13 times 4, because I can't do that in my head. 3 times 4 is
12.
12, good, carry the 1. And then 1 times 4 is 4, plus the 1 is 5. Ooh, I was close. Instead of 62, it's 52, right? So now my fraction is out of 100, which is the hundredths, correct? So I got 100 on the bottom, which is actually my hundredths place. So what am I going to put right here? It's going to be 4.52. So my answer is 4.52. Is that the way your teacher wanted to do it, or did your teacher want to divide it out?
She wanted to turn it into a decimal.
Well, we did. So your answer is 4.52. You're a decimal. We got the answer, but maybe that's not the way your teacher got it. So let me show you real fast how you could do it the way your teacher probably wants you to do it. Is you got 4 again in the decimal place, in the whole number place, right? And then 13 over 25, your teacher probably wants you to use long division. So the 13 would go inside your division bar, right? And your 25 would go outside. Does this look familiar?
Yeah.
Okay, good. That's probably what you're doing. Okay, so does 25 go into 13?
No.
No, so we're going to put a 0 there, and then we're going to throw our decimal place on here, okay? And then we're going to put our 0 there. So does 25 go into 130?
Yeah.
Yeah, how many times? Let's see, 25 goes into 100 4 times. So 25 goes into 130. Would 5 times be 125? Let me double check. So 25 times 5, let's see here. 5 times 5 is 25, right? 2 times 5 is 10, plus 2 is 12. So is that 125?
Yeah.
So 25 goes into 130 5 times, right? And then 5 times 25, we just did that, is 125. And so now I just need to subtract. And 130 minus 125 is? You got that one? 130 minus 125?
Oh, that's a 5.
Good, 5. There we go. And now you bring your 0 down. Does 25 go into 50?
Yeah.
Yeah, nice and pretty, right?
Mm-hmm.
So 25 goes into 50 2 times, and it goes in there evenly, right? So that would be 50 with no remainder left. So your answer is the 0.52. See how we got 0.52 again? Which is what we got before. So if I scroll back up here, that's what we got when we turned the decimal place into 100. So where did the 4 come from again?
The whole number?
Good, the 4 was the whole number. So that's we just ripped off and put in the whole number place, right? And then the fraction you had to do long division on to figure out what that decimal was. Great job, very good, there it is.
Nicely done. If you do have some more problems like that, we do have phone tutors available until 5:30, and actually you can see it on air once again until 5 o'clock. Well, Coral, I know that you've been sitting here and you've been watching a couple of math problems being worked out. Did you know how to do both of those math problems?
No.
You know how to do mixed numbers, right?
Mm-hmm.
Can you multiply mixed numbers?
Yes.
Okay. And could you turn that one into a decimal? You think you know how to do it now?
Maybe.
Maybe. Well, you know what? We're not going to make you do any type of problem like that. We're going to give you a harder one today. How about that? All right. Let's go ahead and take a look at the problem that Coral is working on. Tex wants to make a lawn in front of his house. He buys enough sod to make a 10-foot by 30-foot rectangle section. All right. One of you guys may want to go up there and start writing down important information.
Okay,
and then
I'll
we'll
do
have
that.
Coral go ahead and work on it with you.
Okay.
So he wants to make a 10 by 30 rectangle for $200. He wants to see how well it grows and how durable it is when played on.
$30 you said?
For $200.
Just kidding, $200. Not the same thing as 30. Okay.
All right, so
Okay.
he makes the 10 by 30 and he spends $200 on it.
Okay.
All right. After a week, he decides he needs more sod, so he doubles the dimensions to 20 by 60.
Okay.
And he sends in $400.
And he pays $400. Okay.
The sod company calls up and says, hey, Tex, nice that you're doing the lawn, but you need to send us more money. Explain why he still owes money and how much it is that he owes still.
More money.
So he did the 10 by 30. It cost him $200.
Okay.
He says, all right, I want to do a 20 by 60, so I'll just double the money to $400. But the sod company says, you need more money, send more money. So we need to know how much more money and why that is.
Ooh, that's a good question. I like this one. All right. Did I do that okay? I took up the whole screen. So if you need more room.
Just erase what she wrote.
What? It's beautiful. Okay, you can just hit the extend page. There we go. So now you can scroll up to look at it, scroll down. It's all yours.
So how do you want to start this,
What do you
Coral?
think?
I don't know.
You don't know? All right. Is there anything we could do? What do we know about the original problem?
He paid $200 for a 10 by 30 rectangle.
Could we draw that?
Yeah.
Whenever it shows a shape, I always draw it. Every time. I have to picture it. I have to see it. So go ahead and draw a beautiful rectangle. Nice rectangle. You took rectangle drawing classes, didn't you? Okay, now what are the dimensions of this rectangle?
10 by 30.
Okay, which side do you want to be 10? Just pick a side, it doesn't matter.
This
10
side?
there we go, 10, okay. And it's the smaller side, so that makes sense. And then which one would be 30 then? Beautiful. Okay, and how much did he pay for that?
$200.
$200. Okay, so maybe put $200 there. So he paid 200 bucks. All right, what's the other piece of information here?
He doubled it and it was 20 by 60.
So now he wants 20 by 60, right? Let's draw that over here. And he thinks, why does he think that it should be $400?
Because 400 is twice as much as 200.
right? And so he's like, okay, well, if I take this and just double it, shouldn't I just take this and double it? And apparently, you can't, because the sod company said, no, sir, we need more money. Okay, so why can't we?
Maybe these multiplied together are different than these multiplied together.
Ooh, good thought. What are these multiplied together?
300?
300 square feet. Is it in feet? Where are we at?
It is in feet.
So we got 300 square feet.
Oh no.
Oh, that's okay. Feet squared. There you go. Okay, what's that guy then? So according to him, though, it should be 600 square feet, yes?
Yes.
Because wouldn't that be double?
Yes.
Hmm.
But it's 120 square feet.
Ooh.
I keep messing it up.
That's okay, you're good. 120 square feet. Close.
I keep making marks.
You just erase it. There we go. There we go.
Okay.
So wait, what's 2 times 6?
12.
Gotcha. But how many zeros does it got?
2. So
Best.
1,200.
There you go. 1,200 square feet. Is that double that?
No.
Do you see why the sod company is very unhappy with him?
Yes.
Okay. So what do we do now?
Subtract 300 from 1,200.
Okay. That's
Maybe.
gonna give, okay.
No.
I don't know. Do you think so?
Yes.
We try it. Let's do it. There we go. I think it's because your little hand's hitting it. Oh, is it? Oh, it thinks your hand is hitting it.
You don't even have to touch it if you get too close.
Ah,
So
don't
you
get too
might wanna-
close.
Yeah.
It's very touchy.
$900.
900 square feet, which means what?
That, I don't know.
Ooh, this is helpful. This is good. Let's see if we can see it. What does that mean? That's a good, what you just did. You just took this minus this, right?
Yes. He needs to pay that much more amount, like not $900, but enough money
That's
to
the square
cover
feet.
that.
That's the extra square
Yeah.
feet that he got. So it's not double, right?
Yeah.
So let's ignore the double idea.
Okay.
So let's just get rid of that. We'll come back to it later, right? Do we know how much he originally paid for it?
Yes, $200.
And that was for how much square feet?
300.
300 square feet, right?
Yes.
But he wants like that much more on top of the original, correct?
Yes.
So how much should he pay? Like, let's ignore the 400. Like, how much should he really pay for the 1,200 square feet that he's buying now?
12,000.
Oh, sorry, 12,
Oh, wait, no,
1,200
no.
square feet. How much money, though, would he pay for that? So how much is 300 square feet?
$200.
How much would 600 square feet be?
$400.
How much would 900 square feet be? Ooh, this is hard to keep track of.
1,000.
Let's see here. Okay, so let's make a table because we got numbers that are changing, right? So let's talk square feet. Oops, wait, just feet squared. How about that? And then dollars. How about that? So what do we know? We know that 300 square feet is how much dollars?
200.
200. Okay, so 600 square feet should be
$400.
400. So
Now, Coral said that correct, but I want to
nine-
know, Coral, how did you know it was 600
400.
or $400?
Because it's twice as much as 200.
So
Right.
this is okay doubling, right? Because that is double.
Yeah.
So this should be double. Does that make sense?
Yes.
But that wasn't double, so we see his problem, right?
Right.
Because it was dimensional. We'll talk about that in a second. So we're getting close, though. What do you think I'm going to do here?
900.
900.
So 600.
Why? Good. But why?
Because you add 200 each time you go up a number, and
Every 300 square feet of sod costs
200.
$200,
Yes.
right? Okay, so where am I going now?
1,000?
1,000? Close.
1,200
Why?
because it's that many square feet.
Which is nice, but that's not why I put it, because how much am I increasing here?
By 3.
By 300, right? Wouldn't that be 900 plus 300? 300 square feet?
Yes.
So what is this then?
900. No.
Well, close. Think about it.
$800.
$800. And you put that right. Good. This is dollars, right? So this is $800. So wait a second. I think we figured this out then, yes? How much money does he need to pay for 20 feet by 60 feet of sod?
$800.
$800. How much? But that's not the question, right?
Right.
What was the question?
Question
How
is, they said he still owes money. Explain why he owes money and how much he owes.
So how much more does he owe?
He owes
He sent in $400, right?
400 more
Why?
because he only sent in 400 in the first place, but he needs to send in 800.
Good. So then I think we need to talk about, so why is it not double?
Because the numbers, like the dimensions, aren't double like each other.
Each dimension is double,
Oh,
though, right?
well, yes.
So like 10 went to 20, right? And 30 went to 60.
But when you multiply them, the square feet aren't like,
Because it's like you squared it,
Yeah.
right? Because you're multiplying length times width, which is like a second dimension, correct? So you're
Yes.
doubling the dimensions, but you're doing something more weird with the area. You're not doubling the area, correct? Which is what that is. How's that, Mr. Kushain?
Nicely done. So
we
you
do
saw
well?
that you still owe $400 more.
Yeah.
And probably a nice way of saying it is saying something like, instead of doubling the area was increased by 4 times. And you take the 300 times that by 4 would be 1,200.
So how did he get times 4? So would you agree, though, that 300 times 4 is 1,200?
yes.
Because we added it to itself 4 times, correct?
Yes.
So that would work. So why is it 4 times? Why is the area 4 times?
Because 300 times 4 is 1,200.
Yes, but even if this was like, let's say that was like 200. If you doubled the dimensions, the area would be 4 times as big.
Oh.
Yeah, so think about it. Let's say that was x, right? And that was y, some number I didn't know. What's double x?
2x.
2x. Ooh, yes, now we're getting into it. Now we're doing some serious math. This is good math. Okay, that's 2x, yeah?
Yes.
What would be double y?
60y? No, 2y.
2y, right? And then wouldn't I go length times width?
Yes.
What's 2 times 2?
4.
4. And then you would multiply the x times the y. But it's not double it, it's 4 times it, because you've doubled this and you've doubled that, because it would be 4xy. You should put that on your paper. I bet Mr. Kushain would give you like major points for like, it's not doubled, it's 4 times, and this is why, because we're doubling the sides, which when you multiply it is 4 times, right? What do you think?
Nicely done.
Woohoo!
Nicely done, nicely
High five.
done.
Yeah. That
So
was good.
Coral, an excellent problem right there. And you're not even through with the problem, but come on over here for
We're
a minute.
not? I thought we were.
That's only the first part.
Oh, that's fine.
All right.
No problem.
But kind of reasoning, that's what I think is the goal behind this, is you see, all right, well, they say it's doubled and the money doubled, but it didn't actually double in size. It went up by even more, didn't it?
Yeah.
All right, you ready to do the next part?
Yes.
All right, we're going to get you a little breather, though. We'll give you a glass of water and stuff, and we'll be back with more right after this. Today we're in San Luis Obispo. We're at Laguna Middle School, home of the Lancers, and today we're here to... Today we're at Laguna Middle School. We're in San Luis Obispo. And with us right now, we have 7th grader Luke. You ready?
Yep.
All right, let's go. We're going to order some numbers from least to greatest, and you'll provide me with a couple of those numbers right now.
All right.
So go ahead and give me 4 numbers between 1 and 10.
5, 3, 7, and 2.
Okay. So if I have... those numbers right there. First of all, would you be so kind as to read those for me?
5,372, 53.72, 57.32, and 5,732.
Okay. You read them perfectly. Is there another way that you could read this instead of saying 53.72? Is there another way to say that?
Yeah.
How would you say that?
53 and 72 hundredths.
Perfect. All right. So we want these in order. Would you like to go smallest to largest? Least to greatest or greatest to least?
Greatest to least.
Greatest to least. So we're going to go with the largest one first.
Yep.
All right. Okay. Which one is the largest? Because they all have the same digits in there, 2, 3, 7, and 5, right?
Yep.
Okay. So what's the first thing you need to look for?
I need to look at the thousands place because that's the largest place in all these
Okay.
numbers. And both of these are the same one, so I look at the hundredths place.
Okay, so you're talking about this number and this number?
Yep.
Okay.
And then if we look at the hundredths place, we have 700 and 300, and 700 is bigger.
Okay. So why don't you go ahead and rewrite that someplace so that we can start our order from greatest to least. Okay, so we've used this one.
Yes.
So I'm just going to kind of put a dash line through that so we know
Alright.
we've used it. All right, what's next?
And then 5,372 is the only number that still has a thousands place, so that would be next.
Okay.
Then should I put it underneath?
Well, it's up to you. Would you like to put it underneath or would you like to put it next to it?
Oh, underneath.
And we've used that one.
And then we look at these two. So they both have a whole number, and then a decimal point, and then they're hundredths. So we look at the tens place. They're both the same.
Perfect.
So we go to the ones place. There's 3 and 7. And again, 7 is greater than 3, so that number would go first.
Even though this has a larger fractional part, 72 over 32, you're saying this number is larger altogether.
Yes, because it has a bigger whole number.
Perfect. All right, so we've used that one.
And then the only number left is 53 and 72 hundredths, so we'd put that one.
So let's go ahead and take a look at them right now in order from greatest to least. So we have 5,700.
Yep.
Right? We wouldn't even read the whole number, right?
Nope.
We just look 5,700 something, 5,300.
Yep.
That makes sense. Now we go down to 50.
Yep.
Makes sense, right? 57, 53. Luke, you took all of those numbers, they had the same digits in there. Perfectly done. Nice work.
All right.
All right, just a reminder, we do have phone tutors available until 5:30. We've got a lot of phone calls and Skype calls to get to, as well as the second part of Coral's problem. So right now we're going to go to a student from Pioneer. Edward, how are you today? Hello, Edward.
Hello.
What grade are you in?
I'm sixth grade.
All right, as soon as you're ready, let's hear that problem.
It is 0.885 thousand divided by 9.5.
So did they write divided by as this division symbol, the line and 2 dots? Is it ever, can you see the problem? Is this how it was written out?
No, I can't see the problem actually.
So is it a division box or is it the division symbol, the line and 2 dots?
It's kind of like the picture how it's drawn out with the line.
Okay, so I just want to make sure what we're dividing by. So,
It's dividing by 9.5.
okay, so I'm going to divide by 9.5. So when I do this problem, you're going to do it by hand, right? We're going to make the division box, correct?
Yes.
And
It's going to be a very long answer. So
So the-
let's make sure, Edward, this isn't 9.5 divided by 0.885?
Yeah.
Is that the way it is?
Yes.
Because it sounds like for a sixth grade problem, that's probably the way it's going to be. So reverse the numbers.
So I'm gonna put inside the box, I'm gonna put the 0.95 or the 9.5.
No.
See, that's the question. The division symbol that they give you, what is the division symbol they give you?
Right. I'm going to bet that it's going to be 9.5 divided by 0.885.
Okay? So I'm going to make a division house, right, the box, and I'm going to put the 9.5 inside and the 0.885 on the outside. So it's actually 9.5 divided by 0.885. Okay?
Yes.
All right. So when we do this division, the 0.885 is out in front and the 9.5 is inside. So do you have that? You have that problem written down?
No, I have it as on the outside 9.5 and on the inside 0.885.
So is that how the problem was written with the division box?
Yes.
All right, so let's go ahead. I mean, whatever way he's got it written down,
Okay.
let's go ahead and do it.
Okay, so let's go ahead and do that. So I'm going to take, and I'm going to take 0.885 and divide by 9.5, right?
Yes.
Okay. So I don't want to divide by a decimal, so I'm going to divide by a whole number, right?
Yes.
So I'm going to move my decimal point and make this a whole number, so I have to move it one place, don't I?
Yes.
And if I move that one place, I'm going to move this one place.
Mm-hmm.
So that decimal point's between the two eights, isn't it? And I'm going to bring it straight up so I don't have to worry about it. So now we're going to divide by 95, aren't we? So let's just get this to be 95, right? I've moved my decimal point. So let's divide 95 into 8.85, okay? And we'll see how far we can go on this. Let me see if I can move this down so I have a little bit more room. Okay, so let's see, 95 doesn't go into 8, and 95 doesn't go into 88, so I got to put a 0 over the 8, correct?
Yes.
And a 0 over the other 8, because 95 is going to go into 885, isn't it?
Yes.
So we've got to make an estimate. How many times do you think 95 goes into 885? Well, let's make a guess. We know what 10 times this is. 10 times 95 is 950, isn't it?
Yes.
That's pretty close to 885. So what's close to 10?
9.
Let's try 9. What's 9 times 95?
9 times 95 is
That's 45 carry the 4, right?
yes.
9 times 9 is 81 plus the 4.
Yes.
So 81 plus 4, that's 85. So that's 885, which is pretty close, isn't it?
Yes.
So when I take 885 and minus 855, I get 30, right? And we guessed 9, so there's my 9 up there. 9 times 95 was 855, remainder 30. Got a remainder, so I have to add a 0 and keep dividing. Now I'm going to divide until it stops or I get tired of dividing, right?
Yes.
I mean, there's a good chance it just goes on and on and on, doesn't it? So let's
Yeah,
see,
just a repeating decimal.
it could be a repeating decimal. It just could go on and on, especially with 95. It could have a lot of repeating. 95 goes into 300 about how many times do you think?
About
95 is almost 100, right?
yeah.
So this is 300, so let's try 3, okay?
Yeah. Yeah.
What's 3 times 95? Well, that's 15, and 3 times 9 is 27. That's 28, isn't it?
Yes.
And what's 300 minus 285? Well, that's 15, isn't it?
Yeah.
And what we're going to do is we're going to stop you right there because this is going to go on for a long time.
Long time.
And this could take the rest of the program.
Yeah.
So what we're going to do
So-
is,
We had 3 decimal places in the problem, so how about 3 decimal places in the answer?
so it comes out to 0.09315.
Okay.
And then we'll go ahead and have him round that, and then we'll go with that as the answer.
So I'm going to say to 3 decimal places, I would say 0.093. Okay, Edward?
Yeah.
Great. Thanks for
All
the
right,
call.
there you go. Nicely done. He's also got himself entered for some Condor tickets. All right, you guys, back to the board. We're going to work on the second part of this problem.
All right.
So we know we are now at 1,200 square feet.
Okay.
So you may want to write down 1,200 square feet. And he paid $800 for that.
That's wrong.
I'll put the, oops, huh, you're fine. Put the comma right here, right there. There you go. Okay. And he paid how much for that?
$800.
$800. Remember that?
Yes.
Okay.
So he wants the lawn to be 100 by 120.
Okay.
How much more sod does he need and how much more money does he need to pay?
He wanted this original lawn,
You're going to add on to that.
adding on to that original size.
So you
Ooh,
want 100 by 120, and I will give you guys 3 minutes to solve this.
3 minutes to solve it?
Now
Okay.
2:57.
Okay, now I'm nervous. I'm panicking here a little bit. Okay, so wait a second. Where did we get the 1,200? It was it 20? What was it?
By 10. No,
10.
20 by 10. No.
20
That
times
was
10?
a 20 by 60.
60. Okay, there we go. So we're now going 100 by 120. Is that right?
Yeah.
Okay, why don't we just look at that guy? So isn't that 100 by 120, right? Well, how much square feet is that?
That's 12,000.
12,000 square feet. Ooh, that's a lot of square feet. Okay, well, if 1,200 square feet costs $800, right? How much, what would we have to multiply 1,200 by to get 12,000?
10.
10. So what do you think you're going to multiply 800 by?
10.
Brilliant. Multiplying by 10 is fun, right? How did you know this was by 10 really quickly?
What?
How did you know that was times 10 to that?
Because multiplying it by 10 adds another 0.
Adds another 0. Whoosh. Now you're done. So there's that guy.
That's the easy way to do it.
Right? So it's $8,000. So this costs $8,000. But correct me if I'm wrong, he already spent $800,
Yeah.
right? For this little piece, because he already like put that in here, right? So how much more does he need? He already spent $800. Now he needs $8,000 total. So how much more does he need? There you go. Beautiful. I see it. I'm with you.
$7,200.
Blam. What do you think?
Nicely done.
Did we do it?
$7,200.
Yeah, in 3
And
minutes.
then what you can do, Coral, come on over here. You can go ahead and write down your $7,200 is how much more he needs. And then what you'll do is you'll take the 12,000 minus 1,200 to see exactly how much sod that is.
Okay.
So you work on that. Right now we're going to go back to Skype and let's see who our next Skype caller is. Hey, how are you today?
Good.
And you're in 4th grade?
Yes.
All right, as soon as you're ready, let's hear the problem you're working on.
I have to use algebra, write an equation to solve.
Okay.
And it says Tyler delivers newspapers. He collected 10 from each customer. He has 5 customers on each street and delivers 2 for different streets. How much money did Tyler collect?
Okay, so let's get these numbers again. What did he start with? I heard 5 customers on each street, right?
Yes.
What were the first numbers you gave me?
10, and then I did 12. So $10
$10, and what was that $10 for?
each customer.
Each customer. All right, and now how many customers?
5 customers
5 customers
in each street.
for each street. 5 customers on each street. All right? And now what are you trying to find?
He delivers 4 different streets.
4 different streets, 4 streets.
And we'll give you about 2 minutes once you get all your information up there.
All right? And so now what are they asking you to find?
How much money did Tyler collect?
How much money did Tyler collect? And you need to write this down, you said using an expression, algebra?
Yes.
All right. All right, so what are we going to do in this problem?
I think we are going to do 10 times 5 times 4. And
Right.
then we have to equal it.
So what we're going to do is we have 5 customers on each street and 4 streets. So how many streets?
4 streets?
So 4 streets. So how many customers altogether?
Oh,
Customers, right?
20?
So that's going to be 5 times 4 to get 20 customers, isn't it? And if each customer is $10, right? So there's my customers. So now this is the money, right? How much you're going to collect. So that's going to be what? $10 for each customer, right?
Right.
Times how many customers?
Times
And we
20?
figured out there are 20 customers. So it looks like our answer is going to be $10 times 20 customers. That looks like what? What's 10 times 20?
10 times 20 equals 20?
Well, it's 20 times 10. How do you multiply by 10? You just add a 0, don't you? So we know that 10 times 20 is 200. So it looks like $200 is how much money he has to collect. Okay?
Okay.
And there's your problem.
All right,
Thanks for
nicely
calling.
done right there. We do have phone tutors available until 5:30. 636-4357 is that phone number. We have Coral, our newest ambassador, is going to be going and telling everybody about Do the Math. And we'd like to say to Yash was our next phone caller, but we ran out of time, so we will definitely get back to Yash and go ahead and work on his problem, as well as all of the other ones until 5:30. However, we need to find out who's going to see the Condors, so how would you like to pick it today?
Sure.
All right, just go ahead, reach in there and grab one of those names of the students that phoned in today, and who is it?
CJ from Washington Middle School.
All right, CJ from Washington Middle School, our first Skype caller of the afternoon. Congratulations. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.